Fundamental law of active portfolio management. Overview of the reading. First concept that we would learn is the two terms, information coefficient and the breadth. Then optimum level of residual risk and changes with information coefficient and breadth. This optimum level of residual risk, we've already seen this in the previous reading. Have we? Yes. And we defined it using a formula. Do we remember the formula? We used which sign? We said omega is equal to information ratio divided by 2 lambdas, and lambda was the risk aversion parameter. In this reading, we want to see the optimal or optimum residual risk as a function of these two parameters, information coefficient and breadth. Then market timing and security selection in terms of again the breadth and the skills. Then a concept called additivity principle. And finally the assumptions of fundamental law of active portfolio management. So it's a relatively small reading. The reading kind of clubs the theory of active portfolio management with some formulas to give us a numerical perspective on the same. So let us first start with the concept of information coefficient and breadth. Now information coefficient, to which we would simply be calling as IC in this reading, is simply the level of accuracy of a active portfolio manager. So for example, let us say an active portfolio manager, there are two managers A and B, and both of them have taken 10 bets in this particular year. 10 bets as in they have taken 10 positions which were inactive in weights. Now out of them, if portfolio manager A had 7 successful but B had, let's say, only 6 successful, then using this data we will be able to capture that what is the information coefficient of that particular manager, and what this will essentially tell us is that what is the skill of that portfolio manager in being able to select the appropriate set of stocks or to take correct bets. Is that making sense? So information coefficient is the measure of managers' forecasting accuracy. It reflects correlation between managers' forecast with the actual outcomes, and of course higher the correlation, higher would be the IC. Now this formula you'll have to write down here. IC is equal to 2 into NC divided by N minus 1. N is the total number of bets on the market and NC is the number of correct bets. See, now think of it, let's build some intuition on the formula. Think of it purely from a binomial probability perspective. Let us say there is a manager who's taken 10 bets in this particular year. 5 of those bets have been successful. Now how do you rate that manager? What is his skill quotient, or how much is his information coefficient? So then what we would say is that he's been being successful only 50% of the time, isn't it? And maybe that 50% is purely a matter of probability, that if you take 10 bets and assuming probability of 50%, 5 of them would anyways be successful. So which means he does not seem to have a significant skill. If you would put this data into our equation, 2 into the number of successful bets are 5 as a ratio to 10 minus 1, how much would that be? 0. That means if you're reaching up to the half, then there is no significant skill in doing that, because then maybe it's purely a matter of luck and there is no additional skill. But imagine some other portfolio manager who has a success ratio of 6 on 10. Then the formula would be 1.2 minus 1, which will give us an information coefficient of 0.2. So for the rest of the reading, we would simply be reading this information coefficient as the skill of the manager. And higher the information coefficient means more skillful is the manager in being able to take smarter bets on the market. Are we fine here? ठीक है. Write down this part. Higher information coefficient is equal to higher information ratio. And that makes sense that more skillful the manager, higher is going to be the information ratio. Are we fine here? Next concept is the breadth. Now, how do you think of breadth? Is the number of bets that a manager has been able to place on the markets. Okay. That means the number of active positions he decided to take on the market. So breadth is the number of independent forecasts made by the manager. Forecast should not be made on highly correlated information sets. Okay, now this is one of the important assumption of active portfolio management, and we will be reaching to this part one more time towards the end of the reading, that forecast should not be made on the correlated information sets. Okay, there is some reason for this. You'll appreciate that in the second part. One bet has to be completely independent from the other bets. That means the underlying source of information cannot be same for two separate bets. Okay, so just to build a initial intuition on this, let us say that a manager has placed a bet, the first bet, that growth stocks will outperform. Okay, this is his first bet. And the second bet that he puts is that low dividend stocks will outperform. Are these two separate bets? No, they're not, because generally most of the growth stocks would be low dividend yield stocks. So therefore the underlying set of information is not independent. This is the same set of information, and therefore we would not consider them as two separate bets. Are you following this? Second example, let us say you're a equity research firm and you're a fund manager. In fact, you're a research house and you're a fund manager. So that research team has given you an information that pharma stocks are going to outperform in this season. And then you put two bets, one on pharma stock XYZ, second on pharma stock ABC. If the information that you've used to take these bets is only this particular report that was provided to you on the pharmaceutical stocks, then again these are not two separate bets, this is only one bet, because the underlying information is again correlated or it's same. Are we fine here? If an analyst follows 10 stocks and makes monthly bets, then his breadth would be how much? The number of times he will take decision, or the number of bets he will place in one entire year, would be 120, because 10 stocks, that means 10 bets a month, and since we are doing it monthly, total 120. So BR, which is an indicator of the breadth, in this case 10 forecast a month into 12 months is equal to 120 forecast a year. Yeah, he's right. If the underlying information is same, that means you use the same information every month, then those would not be independent. But if you've used the underlying information which is uncorrelated with each other, that means every month there was a new set of information available, then these would be 120 bets. Are we fine here? Now the fundamental law here, and this is the core of the reading. So now they've presented us with one more formula of information ratio, but this is more of a theoretical perspective on the formula. So what they're saying is information ratio is a function of skill of the manager and coverage of the manager. It is linearly related to skill of the manager, but non-linearly related to the coverage, which means if you increase coverage, the ratio will increase by root of 2, by root of that value. So if you double your coverage, your information ratio will increase only by root of 2, since we have under root BR here. But if your IC quotient increases, then your information ratio will start increasing in a linear fashion. Is that making sense? Now this sentence I picked up from the CFA text, and I think it's kind of conveying the meaning. It is important to play often, which is the breadth, the number of stocks you have on coverage, and it is important to play well, which is the skill of the manager. Should we go ahead from here? Now the sentence is based on this formula. Manager can increase their information ratios by improving accuracy, and improving accuracy is a function of information coefficient, and or increasing the number of bets they make, which is your BR, keeping IC constant. But if you try to increase your coverage and then your information coefficient decreases, then we might have a variable impact on the information ratio. 1.16. So now we would say information coefficient into root of BR. Information coefficient is 0.3 into BR would be 15 into 12, 4.024. Are we fine here? Let us see if we can do one more. 5.69. Now you will have information coefficient into root of BR. This would be 0.3 into 30 into 12, since we are placing these monthly weights. Are we good to go ahead? Now see, what was the first answer? 4.02. And second answer? 6, 9. Can you please do 5.69 divided by 4.02? 1.41. Can you take under root of 2? 1.41. Why? If you would observe here, from 15 stocks here, now the stocks doubled. That means your BR has doubled, but since BR is a under root function in that formula, your coefficient ratio, information ratio, has increased by the root of 2 function. Is it fine? 0.1 into 50 into 4, 1.41. Yes, how much? 2.82. In this case, since information coefficient has doubled, the ratio is going to increase by a factor of 2. Are we good to go ahead? Slightly different question. 16. So you would say information ratio is equal to information coefficient into root of BR. Information ratio is 0.8. This is 0.1 into root of BR. So root of BR is 8, which means BR should be 64. And since we are making the bets quarterly, are we? Therefore, the number of stocks that we want is 16. 32. In this case, we will simply say 64 divided by 2, 32 stocks. Are we fine? Okay. Now it kind of, now think of it this way, that we want to calculate information ratio of a firm which has got two portfolio manager A and portfolio manager B. We have their information coefficient data, we have their breadth data, but we want to find out information ratio of the entire firm. So then that ratio of firm is going to be calculated using the additivity principle. So this is one scenario, but a more realistic scenario is, okay, this is more hypothetical, but let us say that there is an analyst X who is currently following 400 stocks and he has information ratio of, let's say, 0.05. Now recently he's been asked to add another 100 bets to his portfolio, but since his coverage has increased, for these stocks he will be able to manage an information ratio of 0.03. So then how do you find out what is the combined information ratio of that manager? Right? So then the principle that we would be using here is the additivity principle, and what that simply would mean is this information ratio square plus this information ratio square, the whole thing under root. That means instead of simply saying a plus b, we would square those values and then we will take under root. So we are not letting them add those information ratios directly here. That is additivity principle. Write down the formula. First example, 50 stocks and we are making annual forecast. Information ratio is 0.08. Now this is information coefficient of 0.08. First question, calculate current information ratio. 0.56. So that would be calculated as 0.08 into root of 50, which is 0.56. If Anirvan decides to follow additional 50 stocks but with an IC of 0.06, so we have additional 50 stocks which has an IC of 0.06. So for this data again we will have to calculate information ratio. 0.06 into root of 50 point, this would be 0.42. So now we have two information ratios. Now we would calculate a combined information ratio using the additivity principle, which would be 0.56 square plus 0.42 square, and then we will take an under root of both of them, which would be 0.7. Is it okay? Let's do one more. Oh, it should have been HS. HS, right? So 200 stocks, quarterly forecast, information ratio is 0.01. 0.28. 0.01 into 800, which is 0.28. Then additional 100 stocks, so that would be 0.009 into 400, which is 0.18. And then a combined information ratio 0.28 square plus 0.18 square under root 0.33. Should we go ahead now? Next 2 points of discussion. How optimum level of residual risk for an investment strategy changes with IC and BR. So in the last session we saw that formula for optimal residual risk was information ratio divided by 2 lambdas, and now we know that information ratio can be calculated as information coefficient into root BR divided by 2 lambdas. So then how will that optimum level of residual risk be affected with IC? If IC increases, then optimum level of residual risk will increase. If BR increases, then optimum level of residual risk will increase. But if the risk aversion parameter increases, then this risk will decrease. What was the formula for value added? Optimum level. Optimum level of value added IR square divided by 4 lambdas, which would be similar as IC square into BR divided by 4 lambdas. And again, if IC increases, VA will increase, BR increases, VA will increase, and risk aversion increases, VA will decrease. Are we fine? So I think, do you want to write this? Not Not required, right? Let's move on then. Market timing is simply a bet on direction of the market, and we have formula given here for information coefficient. Have you already seen this formula? Let's do an example. Point 2. How will we calculate? 2 into 60% minus 1, that would give us information coefficient of 0.2. We can calculate IR. We have IC now. IC is how much? 0.2. And he makes a bet every quarter. So that means we are looking at root 4. So that would give us 0.4. Okay. Changes in IR by additional sources of information. This point we have discussed earlier. Different forecasts should be independent. That is, two forecasts should not be based on information that is correlated with the. So forecast 2 should not be based on the information which was correlated with forecast 1. So what they have discussed here is a scenario where you are making a decision 12 times a year, but you are using the same source of information. That is similar to having just made one bet the whole year, isn't it? You're just rebalancing your portfolio. You're not making separate bets. Dependence of information sources can lower our IC. That means if you have if you're making multiple bets, so think of it this way, that you've made 5 bets and out of 5, 4 have come out to be correct. So using this you would calculate an information coefficient. But what if those 5 bets were actually based on the same information? Then it is not 4:5, it is just 1:1 right now, isn't it? That means that it might lower that information ratio or information coefficient. That's it. Now see, think of it this way, that we have 2 sources of information. Okay. Now using the first source gives us some advantage, so we have an IC there. Using the second source also gives us some advantage, so we have IC here. But then what we realize is that first source and second source are correlated sets of information. That means that 70% of the second source is actually coming from the first source itself. They are correlated. So then what we would say is that this IC is giving us a wrong indication, because that IC was anyways captured at this particular level. So what we are concerned is only that additional excess source which is going to help us enhance our IC further, right? So they have proposed a formula to find out that combined or modified RC using both the sources of information, which is here. So you would write this down as IC combined is equal to the original IC into under root 2 divided by 1 plus R, and R being the correlation coefficient between 2 sets of information. So now think of it this way. Imagine that correlation coefficient was a perfect 1. That means, are they different set of information? No, they're just 1. So there is no addition to your IC, because your numerator denominator would be 1. So your IC combined and old IC would be same. But if your correlation coefficient, it's let's say 0.7, then this number would be a slightly higher value, and therefore it might enhance your IC to some extent. So based on the level of correlation, we'll be able to find out what is the combined information coefficient of those 2 sources of information together. Is it fine? And the last LOS, which is assumptions of fundamental law. First one, a manager has accurate knowledge of his skills. He knows what he knows, and he knows what he does not know. That means he has ability to understand what are his skill sets. Second, sources of information are independent. We've already spent good amount of time on this. And the third one, IC is same for each bet, and if it is not same, then we have to use the additivity principle. Are we fine? Good. So thank you, and we are through with the reading, not with the session.